Hello and welcome to the podcast on lead-acid batteries by Ramesh Natarajan. With industry experience of over 42 years, Ramesh helps battery and battery-related industries with technical inputs and provides solutions to typical problems faced by manufacturers, service personnel, as well as users of batteries and related equipments.
Greetings and welcome to my podcast for today. Today I'll discuss some seemingly straightforward procedures with hidden dangers and complications that might negatively impact battery life and performance. I have attempted to explain the crucial phases of paste mixing and pasting. I have also uncovered the trade secrets of established manufacturers in this field. You shall need to pay attention to this episode. The rewards for you will be the finest practices and the secrets that many professionals withhold. First, let's talk about the grids. Grid aging is a critical element in the process. This is accomplished by using a dedicated aging chamber. It can also be done by carefully stacking the grids on pallets for several days. The aim is to achieve grids that are hard and firm to paste. Lead oxide is the primary ingredient used in the manufacturing of paste. Lead suboxide purity has a direct impact on battery performance. The oxide's ability to absorb acid and the distribution of particle sizes are essential for creating a high quality paste. Upon receiving oxide, a battery manufacturer's laboratory will typically check the following parameters: free lead content, apparent density, water absorption, acid absorption, and oxide retention on a sieve. Please be aware that battery plates with larger particle size lead suboxide will last longer but have less capacity than those with smaller particle size lead suboxide. The composition of the paste varies according to the kind of battery and its operation parameters. There is no single solution that works for everyone. It is therefore difficult for me to offer a standard formula. Please send me an email if you require a commonly used and proven formula. I'll be happy to share it. The additives to be used for the mixing operation must be pre-weighed. It must be stored before the mixing process is initiated. These additives must be stored such that substances intended for dry mixing with the oxide and substances intended for mixing with water are kept apart. The quantity of additives specified to be used must be in proportion to the oxide quantity. The appropriate paste density, porosity, and consistency must also be considered when determining the appropriate amounts of water and sulfuric acid. Battery manufacturers frequently adjust the acid specific gravity, volume, and water to create the necessary crispy paste. An essential factor in the manufacture of paste is the acid to oxide ratio. Paste density measurements and penetrometer readings are part of the routine quality assurance testing, carried out usually after the mixing cycle. The penetrometer readings are subjective and indicative and not very accurate. When the paste is prepared and ready for pasting, it should be allowed to cool to around 43 degrees Celsius before dumping from the mixer and considered suitable for pasting. It is necessary to verify the paste temperature if it is going to be dispensed into the pasting cone. Evaporation causes the hot paste to lose moisture. The loss of plasticity due to this makes it difficult to apply such paste to the grid. Whilst on the topic of paste temperature, I would like to read an important paragraph verbatim from the Storage Battery Manufacturing Manual by Nels Henner. I quote, "The matter of maximum pasting temperature is not always understood, and if they are understood, they may be ignored. Paste temperatures should reach a maximum of about 150 degrees Fahrenheit, that is 70 degrees centigrade, for best overall results. Higher temperatures are not advantageous and take a longer time to cool down to usable paste temperature. Once the maximum temperature is reached, it should be cooled as early as possible, usually with cooling air and, if available, with jacketed cooling water. The advantage of a temperature peak and cooling is that it assists in producing a paste that travels and shears easily, a desirable property. Sulfuric acid's action to hot oxide produces a more desirable paste than the action of an acid to oxide at temperatures that are at least 20 degrees Fahrenheit lower, that is 9 degrees centigrade lower. On the other extreme, some paste mixing operators may take a shortcut and apply the maximum cooling capacity of the equipment to the mix early in the mixing cycle. The overall result is that it is easily cooled and the paste may not reach above 140 degrees Fahrenheit, that is 61 degrees centigrade, a value that produces very poor paste characteristics. Such a paste has a dead feel and is more difficult to handle in the pasting machine." End of quote. Battery makers should take note of this crucial paste mixing specification. If they are continuously cooling the paste mixer without letting the mix temperatures rise to 65 to 70 degrees Celsius during the addition of acid, the paste quality is bound to be of unacceptable quality. It is necessary to begin cooling only after the paste reaches a temperature of between 55 and 57 degrees Celsius and it is continuously rising beyond that. So you should start the cooling around 55 to 57 degrees. The temperature will rise up to 65 or 70 max and then start the cooling. Once the paste has been prepared, it has to be taken to the next process, that is pasting. At times, it is observed that the paste is dry. To make up for the water loss, pasting machine operators occasionally add water to the pasting hopper. This is undesirable and not a practice to be encouraged. On the other hand, excess water in the paste is also not desired. It causes processing difficulties. The paste sticks to the belt and gets pulled away from the grid. Such a phenomenon is observed on the belt of the flash dryer when the pasted plate is transported from the pasting machine to the flash dryer. A good paste should feel crisp and have a smooth plastic consistency. It needs to be applied such that every square millimeter, square mm of the grid surface is in touch with it. This can be achieved by making sure that sufficient pressure is used to compress the active material into the grid. In case such a bond is not established, the battery's internal resistance can increase, compromising on the battery output. The manufacturer must not think that the curing process in the later stage will help the adhesion of the paste to the grid surface. Overpasting is another crucial issue that needs consideration. When battery makers discover that their battery is underperforming, they frequently turn to overpasting. Please note that it is better to apply the paste in line with the grid frame. I have experienced that overpasting causes more problems than it solves. It is not easy to restrict the extent of overpasting once a go ahead is given to the operators. Excessive overpasting can lead to positive plate bending. It can cause the shedding of paste in the case of both positives and negatives, leading to shorting. Additionally, it can also increase the internal resistance of the battery due to an increase in the path for electron conduction from the outside of the active material to the grid. Once the grids are pasted, it goes through the flash drying oven before curing. In certain cases where hand pasting or slow speed machine pasting is used, the pasted plates are taken directly to curing after the pasting. Some battery manufacturers subject the pasted plates to an acid spray or acid dip, especially in low humidity environments. The mild acid coating is done immediately after the pasting operation and before the flash drying operation. The acid coat forms a thin layer of lead sulfate on the plate surface. This layer helps to retain the moisture within the plate. The acid spray or dip started as an activity carried out to seal the plate surfaces and prevent visible cracks on the plate surfaces. Cracks on the surface of the plate's active material are undesirable. Reports of improvement in reserve capacity performance due to this acid coating have made this activity a part of the plate making process. When pasting is followed immediately by curing, the acid spray or dip is applied right away before moving the plates to the curing chambers. It is important to make sure that the paste density is not changed due to acid coating. The plate moisture range has to be maintained without degrading the quality of the plates. Sulfuric acid in the range of 1.050 and 1.100 is generally used for acid spray or acid dipping, that is 1050 and 1100, between 1050 and 1100. The operators must ensure that the specified specific gravity is maintained by regular and periodic monitoring. As previously stated, it is not advisable to add water to the paste in the hopper. The extra paste that is scraped off the belts during usage of the pasting machine, however, needs to be refilled into the hopper. If this paste is removed from the tray beneath the hopper after a lengthy period, it can be dry and may require water to be added. It is important to take caution to avoid using too much water and changing the paste's consistency. To maintain the right consistency during the shift, the surplus paste must be regularly collected and shoveled into the hopper. Pasting machines are now made with an automatic paste return option to prevent the variability caused by human interface. From the standpoint of process consistency, this is a significant development. From a quality perspective, it is undesirable to switch from a continuous pasting method to a batch procedure that affects the consistency of the paste. I'll now suggest a few quality standards that the majority of reliable battery manufacturers usually follow. 4.0 to 4.3 gram per cc is the recommended density for automotive positive plates. 4.3 to 4.6 gram per cc is the recommended density for automotive negative plates. 4.3 to 4.6 gram per cc is the recommended density for industrial pasted positive plates. And 4.4 to 4.6 gram per cc is the recommended density for industrial pasted negative plates. As regards water in the paste active material, before the plate enters the flash drying oven, please note that in positive automotive plates, the optimum range for the percentage of H2O is 11 to 16%. In negative automotive plates, the optimum range for the percentage of H2O is 13 to 14%. In positive industrial plates, the optimum range for the percentage of H2O is 11 to 14%. And in negative industrial plates, the suggested range for the percentage of H2O is 10 to 13%. The percentage H2O recommended to be present in the active material before the plates are cured is between 7 to 10%. The suggested temperature at which the plates must exit from the flash drying oven must be in the range of 25 to 35 degrees centigrade. It is crucial to check the pasted plates' moisture content before placing them in the curing chamber. The curing reaction is triggered by this moisture and the temperature. Water is the catalyst for the reaction that oxidizes the free lead content in the plates. I shall now state the functions of the flash drying oven. It controls the moisture content of the plates so that the active material has enough moisture before the plates are put for curing. It ensures that the surface is dried without the plates sticking to each other. It provides heat to initiate the curing reaction when the plates exit the flash dryer and enter the curing chamber. As regards the setting of the flash drying oven, now that the plate quality output parameters are known, it is easy to set the oven. Just two parameters need to be established and defined. Oven temperature and speed are the two variables. The throughput is determined by the oven speed. Having a single setting for every plate may seem convenient when preparing the standard operating procedures. The parameters must be adjusted depending on plate grid designs and active materials because both the moisture content of the plates and their temperature when they emerge from the oven are crucial. Certain battery makers and operators believe that the residual moisture in the plates after the flash drying stage is not important because the plates will be placed in curing chambers that have temperature and humidity controls. It is important to realize that the pasted plates require moisture to go through specific procedures during flash drying and curing. The uniform moisture content in the plate pores during flash drying and curing guarantees both the cohesiveness of the active substance and an appropriate dispersion of particles. Additionally, it ensures that the active substance will properly adhere to the grid surface. Coming to the last point, though this is a basic matter that most of the battery manufacturers are usually aware of, I do not want to miss this point since it is a very important point just in case someone does not know. Kindly avoid combining good paste with any leftover positive paste. Kindly discard the paste if it is contaminated. If not contaminated, combine it with the negative paste. Please limit this to 10% of the total weight of the oxide batch. Add the remaining negative paste to the negative batch if you have any. Please limit this to 20% of the total weight of the oxide batch. Never combine the positive mix batch with the negative paste. Before utilizing the machines for positive paste mixing or positive plate pasting, make sure that the paste mixer and the pasting machine's hopper are completely cleared of any leftover negative paste. The positive plates are damaged in case they come in contact with the expanders used in the negative paste mixing. Such plates need to be scrapped. Before being dumped from the mixer for the subsequent pasting operation, the remix wet paste, if any, must be added to the fresh paste batch. Add the remix paste when the new batch is still hot and undergoing cooling after the acid addition. Should you have any remaining paste that has solidified into a lumpy dry state, please discard it. This dry paste is not to be used. I hope this episode of my podcast was useful. Thank you for listening and have a nice day.
Please do visit www.rameshnatrajan.in. Keep yourself updated about our new releases by hitting the subscribe button.